So 144 is our start. So 1 to 6, if all you did is write yes, no, I'll be asking you to add on a little more level of detail. What was I hunting on 1 to 6 to see?
Put it to the right form.
Yeah, what form are we hunting there?
Standard form.
In that
Or like y.
slope-intercept form, which is
Y equals mx.
y equals mx plus b. So on 1 to 6, you need to make these equations be y equals. So like on the first part of 1, you don't have to copy down what you already had. It already did have the y alone, so I don't care about that. But the second one, I'd want you to write that in y equals form. Now, number 2, the first one is already in y equals form, but the bottom one isn't. So we need to get these written in y equals form for 1 to 6, and then you make your judgment. So parallel means two things. What's one of the things that parallel means happens?
Same slope.
Same slope. How do you know the slope?
It's the one without the
Which
x.
one is that?
The x.
It's the one that's next to the x. And then what else do we need other than same slope? Different intercepts. The intercepts are those other numbers. So 1 to 6 is going to go yes, yes, no, no, yes, yes. If you need some help on that, let's do it. But one group, it'll go yes, yes, no, no, yes, yes. Anybody need help on 1 to 6, getting them y equals, knowing what's what? Yes, sir.
Can you do 4 real quick?
4. Okay, so 4, if we get that first y alone, we need the 8 to move on out of there. So negative 6x would sit, and I'd subtract the 8 out. You good with that?
Yeah.
For the second one of 4, we need the y alone. So the 5 is going to sit, and then the minus 2x, I would add that one out of there. So we'd have a plus 2x getting out of there.
Okay.
You okay with that? So slope on this, anybody just yell?
6.
Or negative six.
Negative 6. Slope on this? 2. So we're ready to say no, because we need the slopes to be
Same.
the same, and they weren't. Good on that?
Yeah.
Anybody else need guidance on 1 to 6, how to get them y equals, or how to make the judgment once you do? 6? 6, the top one already is y equals. The bottom one, if you make it y equals, you'll have to divide by negative 3. So the 21 will get turned into who?
7.
Close?
Negative 7.
Negative 7. Okay, so if we go and divide by the negative 3, the positive 21 will turn into a negative 7. You with that? Okay, that tells us the intercept or the slope? The one that's with the x. That's the slope. So at that point we know the slopes are the same. So that's good news or bad news? Good news. You good with that so far? Okay, if we divide, it doesn't even matter what the 7 becomes. The question is just, is it going to be different than the negative 9? So if we go ahead and divide by the negative 3, it doesn't even divide evenly. But the question is, will that be different than negative 9? And that's also, yes, it's going to be different. Anybody else 1 to 6? 7 says write an equation. So when it says write an equation, what's the name of that game? No, you keep working that standard form. Nope. Eventually it's going to work, yeah. Point slope. What's point slope form look like? Y minus equals the slope. Correct. So we'll need to fill in a y there, fill in an x there, figure out a slope there. But this is the setup of how all of these 7 to 12s are going to get created. But once we set them up, what do we have to do to the parentheses side? Distribute, and then we're going to have to do an add or subtract opposite to get the y alone. So I'll tell you 17, and then we'll hunt the final numbers for the other ones. Or 7, excuse me. 7's going to go y equals negative a half x plus 17 halves. If you didn't get the negative half for the slope to put here, that's going to just wreck the thing from the beginning. So the first issue you need to resolve on that one is get the equation that they gave you, y equals it should have shown you a negative half, and then if you distribute the negative half and do it right, you should get y equals negative half x plus 17 halves. If you don't like impropers, 8.5 or 8.5, it's just as good. Let's troubleshoot that one if we had trouble with that one already. Anybody 7 trouble to figure out what happened?
Yeah, I had some trouble with number 7.
Okay. Did you get the equation y equals?
Yeah.
Okay. When you got the y equals, do you see a negative half? Okay. Negative half lives here then.
Yeah.
This is going to be a 7. This is going to be a 3. Did you get that far? Okay. Then try to work it from there. Do you understand why I put the 7 here, why I put the 3 there? Then you're going to have to just distribute and go. Anybody else 7, trouble getting that set up? Okay, 8, y equals blah, 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 some xy stuff, and then anybody have a whole number at the end of 8? Y equals this, x, blah. Whole number at the end, anybody?
Positive 3.
It is positive 3. 9, y equals some fraction-y x stuff, and then a fraction-y finish. Anybody on 9 have a fraction-y finish? Maybe? Negative 17 over 7, yes. 10, y equals a whole number amount of x's, and then finishes with a whole number that involves luck. No. Negative 13, the famous unlucky number. 11, y equals fraction x stuff, but then a whole number finish. It is, what'd you say?
Positive 4.
It is positive 4. On 12, y equals a negative fraction amount of x's, and then has a fraction finish. I think it's the weirdest answer we've seen so far.
Negative 35 over 2.
It is negative 35 over 2. Good. Anybody need help getting to that point? We've got the finish line established, and only you know, you're looking at your papers, whether you can do it or not. Anybody need some help making the magic happen to get it to the finish lines? A 13 to 16 is another group of yes-nos, but if all you wrote is yes-nos, I'm going to ask the same of you on as 1 to 6. What did I want to see on 1 to 6? Did I also want to see 13 to 16? Oh, slope intercept 4, which means
That's y equals.
y equals 4. So 13 top one is already y equals, so you don't have to write that down, but the bottom one, you should write it in y equals 4. This makes yes, no, no, yes, is that group of 4 on 13's group. Yes, no, no, yes. Question about 13 to 16, help.
Wait, what?
Anything 13 to 16,
Do you
Steve?
have to do a word for 16 since they're both y?
No, they're both y equals, so you could just judge it. It's nice when they do that to you.
What were the answers? It was
Yes, no, no, yes. Anybody need help on those? Okay, 17, the first 3 words are write an equation. So as soon as you say write an equation, I'd say 98% chance that we're using one sub form. So we're back to this. We're going to go y minus a y they give you, x minus the x they give you. The trouble here is going to be the slopes. And sometimes people just get this one jumbled up because they got in a certain habit on 7 to 12. How is 17 to 22 different than 7 to 12?
Is it perpendicular?
The perpendicular, so how do we do the slope differently on perpendicular?
I'm looking at the left side of the page. Is it substituted?
No. Anybody? Perpendicular, what's the difference?
negative reciprocal.
Negative reciprocals. So a minute ago, when we looked at this one, the problem had a negative half, so we just went with negative half. But on this group, if the problem has a negative half, what do? Positive 2, because we have to switch the fraction upside down, and we have to switch the sign. Negatives become positives, etc. So 17's group, again, you need every equation to make it y equals. Once you make it y equals, you'd have a slope, but that slope needs like all changed around. 17 I'll say is y equals a half x plus 4. When you do the y equals, you should see a negative 2. If the y equals, when you see a negative 2, you have to transition that from negative and 2 into positive and half to live here. Final answer will be y equals a positive a half x plus 4. Anybody need some help to troubleshoot 17 to get on good footing for the rest of the group? 18, y would equal a negative whole number and then have a whole number finish. Anybody on 18 have the whole number finish? It is 12. 19, y would equal a positive fraction x, but then finish with a whole number. Anybody have y with a positive fraction x and then a final whole number? It is negative 6. 20, y equals a negative fraction of x's, and then finishes with a pretty weird fraction. It's not that different than 12's weird fraction. Maybe it's a little different, but negative 6 and a fifth would work. It's negative 31 over 5 if you leave it improper. So that caught my eye because 12 was in the 30s. This one's in the 30s also. But negative 31 over 5 or negative 6.2, whatever you like. 21 is a 2%er problem. Anybody know what I mean by it's a 2%er problem?
You only got the y, so you can use the mx. M equals.
We can go straight to y equals mx plus b form. We could do this, but why do we catch a little bit of a break on 21 as well as an earlier one? What's different about 21 that it's a little easier to do because of a certain choice they made as a book author?
It's like they always put it in the right order.
No, there's something different about 21. They gave you a y-intercept. If the ordered pair they give you is 0 something, you can go straight to slope-intercept form once you have the slope. So it's going to go y equals a positive fraction x, and then a whole number in the end. Any positive whole number finish 21?
9.
It is 9. Which other problem did they give you a y-intercept earlier that we could have done straight to slope-intercept form without this? I keep writing this up every day and say, write an equation, there's a 98% chance we use this. The other 2% is when they give you an intercept, you can sidestep it. If you, which number? 8. 8's the other one like that. If you want to use this though 100% of the time, can you?
Yeah.
Yeah. Okay, but 2% of the time you can shortcut it with slope-intercept form. 22, you're going to get y equals a positive whole number for the x, and then another whole number for the finish. Anybody with the final whole number finish on 22? It is negative 10. Does anybody want some guidance on that group? Then 23 to 28, they tie together a bunch of different ideas. They're all worked on themes that we've had. It's just in a little different way each time. So here's some just general advice. Again, when they say write an equation, what are we going to use? Point slope form. 98% up to 100% of the time. So a lot of these questions say find an equation, find an equation. You're going to need to work through this. That's a thing. On a couple of the equations, or a couple of the problems, they give you an equation. So if they give you an equation, what do you need to do with any equation they give you? Make it y equals. So if you're looking at like number 26 or 27 or 28 where they give you an equation, what you need to do is make it y equals. On some of the questions, they give you a pair of ordered pairs. So there's like 2 sets of coordinates given to you. If they give you 2 sets of coordinates, what's your move pretty much always there? If they say, here's an ordered pair, here's an ordered pair, what is your move? Find the slope. So if you're looking at 23 where it says containing this and that, 24 containing this and that, take those two ordered pairs, the this and that ordered pairs, find the slope. That's going to be your key move on 23, 24. 25, they give you 3 ordered pairs. So what do you think you would do on 25? You could, I wouldn't. So if they say this and that, what you do, you take that and you find a slope. If they give you 3 of these,
You do that 3 times.
you do that 3 times. You could do the slope using the first 2. You could do the slope using the
2 and 3.
last 2, and you could do slope using first and last. So what they have in mind for you to do on 25 is do the 3 different slope combinations and then just see what happens. Other key ideas in this, if slopes ever turn out to be the same, you know that the lines are parallel. You can also tell if things are perpendicular because they are right angles. It's true. Negative reciprocals on the slope is also true. But those are the ideas in 23 to 28, but every question is different. 23, I'll tell you, you got it right if 22/3 is your final number. 24 you did right if 41/12 was your final number. 25 you did right if you did these 3 slopes as we just described and you noticed some perpendicular stuff in there. There will be 2 perpendicular friends out of the 3 slopes and then 1 misfit. So in other words, if I saw 3/4, 3/4, and 7/8, if that's my trio, what there catches the eye? What there do we know just happened? 2 of the 3/4 makes 2 of the lines be parallel. If I had 2/3, 3/2, and -3/2.
That's 2/3 and -3/2.
2/3 and -3/2 mean that 2 of the lines are perpendicular. Okay, so 25, two of the fractions should catch your eye to be set up as perpendicular. 26, get everybody y equals, and then you're going to get, you'll have 4 numbers. 2 of them will create perpendicular stuff. So you're going to get not a series of 3 numbers, you'll get a series of 4 numbers. So if I'm looking at this series of 4 numbers, out of A, B, C, D, who's the perpendicular guys? A and D, I agree, as well as B and D, because A and B are the same. So on 26, if you do it right, you get all the lines y equals, you're going to get 2 of those pair off to be perpendicular friends. 27, if you finished with a 5/7, you probably did the right thing. 28, if you finished with a -0.6, you probably did the right thing. I could layer in some more details other than that overview I already did, if that's helpful. Anybody on that last 6 where they're all kind of different, something I can layer in some details there for you. 28. Okay, so 28, did you get the equation y equals? Or not yet? Okay. Do you know how to get that equation y equals? Okay, go ahead and start with that. And once you get the equation y equals, then circle back to me and we'll talk again. Okay? Anybody else? Something on 23 to 28 I can get you started with. Have a conversation about it. Do you see a +2 yet? Okay. So that's the slope. Okay, the line you just did has a slope of +2. So you want to be perpendicular. So Are we keeping that positive 2 to be perpendicular, or are you switching it around? Switching it around. How would you switch the positive 2 to stick into this slot for slope?
Do that.
It'll be 1/2 and one other change. Negative 1/2. Yeah, so we're going to go -1/2 there. And then the 1.2 is going to go here. And then the other number goes there. And then are you good again? You're good at that point. Okay, last call. Anything 144 I can help you clean? Okay, if those are done, send those down. If you're still working, we'll talk about that in a minute when we're not recording. I'm going to take a step up into 3.8. I'm only going to do one example problem. I'm going to do, for homework, we're going to do a 1 to 5. So there'll be 5 problems about equivalent to what I'm about to do in this empty space. I'm working from page 148. Page 148, in the middle of it, there's a bright red, try this, it says. So here's today's main obstacle is get over the fact that there's a paragraph to read. We're going to have to grab the numbers out of the paragraph, but once we grab the numbers out of the paragraph, we're just going to do what we've been doing. So if getting over the fact that there's a word problem gives you a panic attack, then this is going to be hard until you can find a way to just like get over it. Think the little engine who could, I think I can, I think I can. If you can get over the mental obstacle of their sentences, you'll be fine, because the math, there's nothing new in terms of math to this. It's the exact same thing that we've been doing pretty much all along, other than one little trick that I'm going to do to try to make the math easier for you. So here we go. I'm on page 148. Try this in the middle of the page. It says records in the 100-meter dash. It has been found that running records change with time according to linear functions. That's sort of true. In 1920, the world record for the 100-meter dash was 10.43. So what I'm going to do is I'm going to look for numbers and I'm going to build myself a little table. So 1920 is the first year. 10.43 was the world record in the 100 at that time, and then I'm going to read on. It says 1970, there's a new world record, is 9.93. Over time, the world records have to go down. Why?
Because it's a faster time.
The only way you get the record is to run a faster time. There's no way to go than that. The records have to go lower. Which means when we do some stuff with, what's the main word of our chapter? The single one? Slope. The slope is going to be what type of slope? Because it is decreasing move. Negative slope. Okay, so if we graph that, it would have to look like this. It has to have a negative slope. 10.43, we decrease it to 9.93. I'm going to read on. It says in the question sets, find a linear function to the data points. That's a fancy way of saying write an equation for the line. Okay, and again, write an equation for the line is point slope form, going to get used again. Then question series 2, they want a 1990, try to figure out where it might head. They want to figure a 2000, where it might head. And then they want you in part 3 to answer someday, maybe in our future, somebody might run a 9 flat. It's hard to imagine that if you've ever run or watched people run 100 meters, but who knows? But someday 9 flat, they want to try to predict where that goes. I'm just going to read the paragraph, I'm going to make a little table, and then it's no longer a word problem. Question about how I built the little table. The years will always be X's, the other numbers will always be Y's. If you peek ahead at the homework, number 1 is about life expectancies. So it's years and it's life expectancies. Life expectancies tend to go up. Why do life expectancies go up? Technology, like medicine got better, surgery gets better, just more known about health. Nutrition gets better, things just have tended to get better over time. There's a lot more vaccines, there's a lot more stuff, but 1 and 2 are about years and life expectancies. 2 was something about years and how much natural gas is getting used. Well, I'd say the amount of natural gas getting used over time, I would expect to go up because there's
More stuff to use gas.
more stuff to use natural gas. There's more people on Earth. There's a lot of reasons for that. There's more countries that are becoming more industrial instead of being like, rural or whatever it was. 4 and 5, we're back to world records again for runners, but again, it's always going to be years and then a number, and the numbers for any running records are going to have to go down. It'd be negative slopes. Question about the concept. So here's what I would do once I'm looking at my table. To make life easier with the math, I'm going to suggest you do this. Take the lowest year and make it the easiest number in math to use. What's the lowest number in math to use? 0. So take the lowest year and make it a 0 because it's nice to deal with zeros. You might say that's not fair. Well, people did that in history. There was a point in history that they decided to start doing AD and BC years, and they kind of like created a cut point, just started to renumber the scheme. But we're just going to take 1920 as the start of our story and say that is 0 year. So if that is 0 year, what year would this become? 50. Why 50?
Because it went up.
Because we're up 50 years later if we subtract. 1990 compared to the base year is 70 later. 2000 compared to the base year is 80 later. So we'll just change that. It's going to make numbers easier to deal with. I don't think you'd be real excited about point slope form plugging in at 1920. I think you'd rather put in a 0. Okay, so if we make the low year 0, we're plugging in like normal numbers and not plugging in 1970s and stuff. Question about that weird little trick, just to try to make the future math a little easier. So then this is a point, this is a point. We've been talking for all week about if you're given 2 points, you want to find the slope. So that's our first move. Take those 2 points, find the slope. The slope has which of the letters on top? Y's. So which ones are the Y's?
The 10.
Okay. So 10.43 minus 9.93. On the bottom then?
0 minus
0 minus 50. On the top, that's a 0.5. On the bottom, that's a negative 50. You're not supposed to have fractions with decimals in them, so grab your calculator and just punch in 0.5 dividing negative 50. That'll be negative 0.01. I would always hesitate there and think, is a negative slope what we were expecting? For world records, the answer is yes, because they're supposed to go. No. But not by much. I mean, it's not like you're going to get a slope of negative 10. The world record is only 10. You can't go down 10 in a year. That seems far-fetched. This is telling you every year you'd expect the world record in the 100 to drop by like a 0.01, 0.01, 0.01. And I'm saying that's sort of true. It sort of averages out that way. Why is that not exactly true? Anybody who's involved in watching sports?
There might be a year it doesn't happen.
Might be a year it doesn't happen, or you might get a year you run into a guy like who? Usain Bolt might appear on the scene at the Olympics and be like, I know what math says, and I'm Usain Bolt, and I say no, and he takes a world record and like destroys it. That happens sometimes. And then that record might not be broken for another 50 years or something, like if Usain Bolt said no. Over time, it still may average out to be this 0.01, but you have your years that it doesn't happen, and you have years that Usain Bolt just has other ideas. But anyway, we've got a slope. That's why I said this is sort of true, you know, boring Usain Bolt. Here's another reason it's not true. I'll save it again. So we've got the slope. Job 1 is write an equation. So 98% of the time, write an equation, you do. Point slope form. I would use this point because we've got the 0 there. And realistically, if we have a 0 there,
And it's just the y-intercept.
it's just the slope-intercept form as well. So you could make this like a 2% question because of what I did there. So you could either go point slope, which you could go y minus 4.3 equals negative 0.01 parentheses
X minus 0.
0. X minus 0 is silly because that's just
X.
x. And then to subtract 10.43, you want to add 10.43. There's nothing wrong with doing that if you like doing that 100 times. But since this became an intercept with our little change-a-rooney, you could just go straight to slope, intercept form, and be a little bit quicker out, in fact. Question about how to do part 1, write the equation. Then part 2 is now more like an Algebra 1 kind of lifestyle, okay? We're done with the equation, but we're going to use the equation in a way we haven't before. So what I'm asking you to do now is take an x of 70 and solve the mystery of what will y be if x is 70. How can you use this and solve the mystery of if x is 70, what y is going to be? Plug in 70 for x. If you plug in 70 to the x spot and grab your calculator, negative 0.01 times 70, adding 10.43 is going to get you 9.73. That is one answer, and that's another answer. It's a real story, so it's always worth thinking, does this make sense? Like if we sort of follow the trend, does that feel like about where that should fall? It seemed like a thing? Yeah. You know, it went down, but not by much. You know, 50 years, it went down by 0.50. 20 more years, it went down by 0.20. It probably stands to reason that in 10 more years, it's going to go down by 0.10. If we want to make sure, take 80 and plug it in. Stick 80 now in for the x. Negative 0.01 times the 80. Add 10.43, and we come out with a 9.63. That's what we expected, that's what happened. It sort of feels about right. We're on board with that. Question about how the part 2 work? You can't do part 2 unless you first are correct on part 1. Part 1 is the whole foundation for getting part 2. Part 1 is also the whole foundation for getting part 3. Part 3 switches it up. Instead of giving you an x and asking you to get a y, they give you a y, and you have to chase down the x. So we're going to take this 9 and put it in for the y. That's going to take a little more work. Okay, 9 is going to equal negative the 01x plus 1043, and then it's opposite algebra time. Who's going first? Opposite Bill. Get rid of the plus 10 by subtracting 10. So subtracting 10 is negative 1.43. Then get rid of the 0.01 by dividing. Negative dividing negative is positive. So we step over here. That is not happening in the year 143. We're not going back to the Romans and Colosseum and Caesars and whatnot. This is not like AD year 143. When is this in the real calendar?
It's 143 years after 1920.
It's 143 years after we started the story. So to figure out the true year, we need to do 143, add on to 1920. Maybe in the year 2063, somebody's going to run a 9. I don't know about that. There's human limits involved in that, so I'm not feeling that as likely to run a 9. Maybe they will. I don't know. I'll be a 91-year-old being proven wrong if it happens, but I'll be surprised that people are running a 9 flat. Question there? Here's a side issue. If I were to graph this graph, 0, 10.43 would go up 10.43. And then with a slope of only negative 0.01, that means it's going to go down, but
Very slightly.
You won't even
very,
notice.
very, very slightly. Okay, we're on a very, very, very slight decline. I would say this is true over small periods. If we took a long enough period, long-term, long-term view, eventually, what would this line do that really, it's just not possible?
Go all the way down.
It would go all the way down until it did what impossible thing?
Go into the negatives.
Go into the negatives would be even more absurd than what it would do first.
Zero.
Go to zero. Eventually, this would have to touch this axis. If it has a negative slope forever, it would touch the axis someday, which would mean, in theory, somebody could run the 100-meter dash in 0 seconds. Okay, that's not a thing.
Jesus.
And then beyond that point, we would go negative, which would mean the person ran so fast that they're like the Flash. If you watch the Flash, what does the Flash sometimes do? He
Slow
runs so
down
fast
time.
that he even better than that.
Goes back in time.
He goes back in time, the time forces and all that sci-fi crazy
like
stuff.
back to the
So,
future, baby.
is this linear thing true? Sometimes, for some things. Over short periods of time, yes. The graph in reality for the running, I think, would be more like this. There's like a decrease, but at some point, it just basically levels off. It's not going to be a true straight line. It's going to be more of another sort of shape we'll deal with later in the year. But we're off topic, but that's just doesn't hurt to think and find some truth there. So is this a lie? No. Is this a complete truth? No. I think this is like an oversimplification. But anyway, long story short, bottom line, all of these stories will be the same. Homework's 1 to 5. Make an XY table. First, there will always be years for your X's, some other item for your Y's. Make the lowest year 0 to make the math simpler and adjust all your other years by subtracting. First move will be find the slope. First answer is an equation either using point slope or slope intercept form. Once you have that equation, then you can answer questions. If they give you a year, it sticks in for X. If they give you the other thing, it sticks in for Y. It's a little more work when you stick in for Y because you've got to do the opposites to get it solved. But 1 to 5 is that. Also, project for tomorrow, study that vocab. We'll do the vocab quiz tomorrow because we don't have a lesson. So usually we do homework, then lesson, homework, then lesson. Tomorrow we go homework, then vocab quiz. I can give you a sheet also today if you're in a work ahead mood. Tomorrow's Friday, so tomorrow, Friday, we'll do this 1 to 5. Tomorrow, Friday, we'll take the quiz. Then for Monday, the sheet will be due. Monday, we'll do a review on the last 4 lessons. Tuesday, we'll take a quiz. The grade period is ticking down on us. We'll have another review. We'll have a chapter test before the grade period ticks away. Homework from this chapter would be due by the test day, which is next week, Thursday. So Thursday, test day, all the chapter homework, what would we do? Friday, we'll start a new chapter. Friday, the grade period ends. That's when any of the fix-it stuff would be due. Most people are owing me some fix-it stuff from chapter 2. So I'd get a move on that soon because the days are ticking fast. Cut that off.